Okay, examples 117.1. Graph xy is an element of the set of real numbers squared. Okay, so big R is real numbers. Squared means that we're looking at a x and y coordinate system with a set of real numbers. So in other words, R squared is just the Cartesian coordinate plane that we're used to seeing. We have a horizontal number line, we have a vertical number line, we have ordered pairs within those number lines. Alright, so that's what R squared means. If they said z squared, it looks the same, but when you graph, you only graph integers, so you graph dots only. Like so. You'd create dots where integers are. 2, 4, 1, 4, 3, 4. There's no such thing as 2.5, 1.5 in the set of integers. Right? So we're only graphing integers in that situation. So they might throw one of those at you. That's the only difference. Is instead of shading a whole bunch of stuff on a z-squared, you're just going to put dots on all the integers. A bunch of dots. It's very dotty. All right. We've already done these problems. This right here is something we've already covered in class quite thoroughly, actually. We've done it with linear equations, we've done it with nonlinear equations just recently, where we graph this line. So if I graph y equals x plus 2, it has a y-intercept of positive 2 and a slope of 1. And I'm going to connect the dots with a dashed line because it doesn't say greater than or equal to, it simply says greater than. So I use a dashed line to graph those dots, that line, like so. Then I graph y equals negative x. That's a y-intercept of 0 and a slope of negative 1. Down 1, right 1, down 1, right 1, down 1, right 1, and so on. We're going to connect these dots with a dashed line also because, again, this is less than, not less than, or equal to. So as long as there's no equals to, then we're going to use a dashed line to graph it. And there's our line. And once we graph both lines, we created our 4 regions. And some of you, I think, like this a little bit better than others. So the other way we did it, so if we just call those, maybe use different letters to represent them, A, B, C, and D. All right, we got A, B, C, and D there. If we first test the blue inequality, I want to pick some test point. I'm going to go with 1, 1. I need a test point that's not on either line. 1, 1 fits the bill. And that's x equals 1, y equals 1 is my test point, and I'm testing y is greater than x plus 2. So if I put 1 in for y and 1 in for x, 1 plus 2 is 3, I say that's false, right? Now look at the dot, my test dot, in relation to the blue line. The test dot is false, which means everything in the same side as the blue dot from the blue line is going to be false. So region B is false, region C is false, A and D would be true. So for this blue line, I would be shading A and D. Whether you get false or true, you can get the right answer. All right? So you don't have to go find a true to find the right answer. So false tells me false, these are false, those are true, I want true. So where's true at every time? If I pick the same test point for the red line, so again I've got x equals 1, y equals 1. I got my inequality that says y is supposed to be less than negative x. If I put 1 in for y, I put 1 in for x. That would be minus 1, right? 1 less than negative 1 is also false, right? Now look at the dot, my test dot here in relation to my red line. My red line's here, the dot's on this side of the red line just like A and B are. So A is false, B is false, D and C have to be true. So I can see that D is true for both of them, so I'm going to be shading D. So I would go this way. Alright? And just to really reinforce what I'm talking about with this whole z squared, if the problem had been this instead, z squared, the red line would still be a dashed line, the blue line would still be a dashed line, D is still the true region, but instead of shading all that stuff, I would only be graphing the integer intersections like so. So if it had said z squared, it would be the purple instead of the red. You wouldn't shade everything, you just shade the integer values. Alright, so hopefully that doesn't happen too often. You get a little writer's cramp. Or hopefully if it does, maybe it'll be a situation like this where one of the line does this, the other line does that, and you have to shade like right here, this little tiny bit, maybe. Something like that might happen. That might be good. But I don't know. But again, if it says z squared, that's how you handle that. It's the same problems we had before. Imagine one of these little braces here. Y greater than x plus 2, y less than negative x. It's the same problems we had. So do it the same way. It works exactly the same way. It's asking the same question, just a different way of asking.